Right.
Let's see. Share screen. Okay, so Blake randomly chose a letter from the alphabet. What is the probability that this letter has at least one line of symmetry given that it is a consonant? So given that it is a consonant, how many letters are you left with? Because some of these, it is easy to use the, some of these is going to be easier to use the formula, but some of these it's easier to just think about, like, if this is the condition, then let's just like use that condition as our like denominator, if that makes sense.
Are we counting y?
No, I don't think so. That's not counting as a well, yes, like y is a consonant, not a vowel.
Right. So then we have like 21 letters.
So 21 letters that are consonants.
Mm-hmm.
And then of those 21, how many can we have, or how many are going to be symmetrical? At least like one line of symmetry. So then you kind of just have to like go through them, right? Like B, C, D.
Capital or?
I guess either way.
Now here's where it gets confusing because like I think
that's something with probability problems and like statistic problems, because like they're wordy, right? And then like it's part of it is actually just understanding what the word problem's asking you for. So I think either way, I think we could do capital or lowercase, but I'm just going to use capital because I would say capital. Yeah.
All right.
I guess that could have been confusing. J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. Right? And that should be 21. 5, 10, 15, 21. Yeah, so there's 21 of these letters. Which ones are we able to have at least one line of symmetry? And it could be like any direction. It doesn't have to be like a vertical line or horizontal line. I think like diagonals could work too, if that.
Right? A line of symmetry is like two repeating lines, right?
It's just a line of symmetry, meaning that like if you were to fold that in half, are they the same? Like, is it symmetrical?
Okay, so then
like for B, if the line was this way, right, like where I'm drawing the dotted line, then it's symmetrical. Same with like C, right? So I'm gonna circle the ones I think we have symmetry. This one's a maybe. I'm gonna keep that one. S. Wait, no, not S. T.
No, it goes both down like the y-axis and the x-axis, like you're pulling both horizontally and vertically.
Yeah, it could go either way. At least one. It says at least one line, so it doesn't really matter where that line is, I think. How many did I circle?
Thank you. Yeah.
8, 9, 10. 10. So I think we are counting K. The answer key says that it's 11 out of 21. So that's why I like put an arrow to K. I think like depending on how you draw your K, it could be symmetrical or not, right?
Isn't
like
A also one that could be used?
But remember the condition, given that it's a consonant.
Oh yeah, it has to be. It's a consonant. Yeah.
Right? Because I think all of the vowels could be. I think all the vowels are symmetrical, but so I think we want to count K because that's, you know, like depending on how you draw K, it could be symmetrical. But I think that the other ones that I didn't circle, those are the ones that wouldn't. Like, there's no way for it to be symmetrical. Or maybe L. I think like K and L are kind of like, but nobody really draws an L with both lines the same length, right?
Yeah.
I think it's K is supposed to be it. So this one should be 11 over 21. Does that make sense?
All right, yeah. And then the next question just moves on to like number 5.
Number 5? Card randomly selected, standard deck. find probability that it is a face card given that a black card is drawn. So same thing. Let's just, instead of like trying to use the formula, let's think about this condition, and now we have a new denominator. Okay, so this one was number 4. Number 5. If we have the condition that it's a black card, how many cards in the deck are left to choose from?
52 totals in the card, so 26.
Yeah, total. So 26. So 26 black cards.
Mm-hmm.
Right, so that should be our denominator. What is the probability that is a face card? So now how many face cards are there? Face cards meaning like those royals with the actual.
Yeah,
like,
jacks, kings, queens.
Yeah, jack,
6.
king. So 6 of them.
Mm-hmm.
Exactly. So 6 over 26. We just need to simplify because it's
3 over 13.
Exactly.
Okay. And then I just had questions on like 10 and 11 because those are really wordy questions.
Okay. I'm gonna open up a new page. 10. Okay, let me take a look. Out of the 125 children at summer camp, 45 signed up for swimming, 38 signed up for arts and crafts, 12 students signed up for swimming, also signed up for arts and crafts. If a child is randomly selected, what is the probability that they're signed up for swimming if it is known that they did not sign up for arts and crafts? Okay, so yes, this is wordy and maybe needs, I don't know about a diagram, but okay, so there's a total of 125 kids.
Mm-hmm.
45 swim, 38 arts and crafts, 12 students who signed up for swimming also signed up for arts and crafts. Okay, so 12 of
So
these.
it's just 33 signed up for swimming but did not sign up for arts and crafts.
So, okay.
The chances are then 33 out of 125.
33 swim. No, it is 33 out of something, but wait, let's see, but not arts and craft. So this is your numerator number. You got that right because it's like, what's the probability they're signed up for swimming? But we know that they didn't sign up for arts and crafts. So we know 38 signed up for arts and crafts of the 125 total.
Mm-hmm.
So how many is that left if we take away those arts and crafts kids?
Oh, okay. Yeah, 125.
Right?
Minus 38, which is?
I just had to do that on the calculator. It should be 87.
Mm-hmm.
Right? 87 don't do arts and crafts.
Okay, so 33 out of 87.
Yeah, there you go.
All right. And then 11.
So 33 out of 87. And then 11. Out of 56 players on the football team, 24 are on honor roll, and 18 have perfect attendance. 7 who are on honor roll also have perfect attendance. If a player is chosen at random, what's the probability they're on honor roll if it is known that they also have perfect attendance? Okay. So of the 56, how many have perfect attendance? That's just our given, right?
Is this
just 18?
7,
so that's going to be our denominator.
Is this 7 out of 56?
Out of 18. So you're right, it's 7 because there's 7. Oh wait, let me see.
Oh, all right. I see. The denominator shows because it's asking because the question asks that they need to have perfect attendance.
Exactly. So now that just cuts away all those other kids,
all right,
all the other football players. Only the 18 are what we're looking at, and then there's 7, right? Because there's only 7 that also are on honor roll. Yeah. So they gave you a lot of extraneous information for that one.
Yeah.
But yeah, that's it. You got it.
Um,
I'm going to stop the share so I can go back over to the share. Okay, so 8 and 9 use that wheel.
with this, is this sort of saying like, is it already designating what the denominator is going to be in the question and how you have to answer it? You can't just, not every question is just going to be like out of 12, which is the total number of spots.
You're asking about the denominator for these problems, for these 3?
Yeah.
So you're right. The denominator changes depending on what that given is, the conditional part, right? So if this is given that it's white, now we don't have to look at all 12. It's just what are the white ones? How many white slots are there?
6.
6. So our denominator will be out of 6. And of those 6, how many are C's? Are the letter C?
1, right?
Should just be one of them. Yep. So
1 over 6.
Just
okay.
1 over 6. Yeah. Do you want to talk through number 9 with me?
Yeah. So it's first asking if it's B or E.
B or E. So how many of them are B or E?
4.
Count again. I think you missed one. There's 3 B's and 2 E's, right?
Yeah, 3 B's. Yep. 5.
So over 5. And then how many of those are black?
3.
3 of them are black. Yep. So 3 over 5.
All right. One time. I think it's 7 wrong. 7 should be what you're saying. It is.
Just look at how many of them are A's.
So it's 3. So 1 and 3. Okay. All right.
Yep. Exactly. Good. You got it.
Thank you.
No problem.